Good evening, sir. My name is CRIS from ACT2E, and we will discuss Lesson 9 entitled Advanced Topics in Graphics. These are the contents of our topic: real-time rendering techniques, global animation and ray tracing, virtual reality, and augmented reality. Real-time rendering is a complex process within the realm of computer graphics wherein 3D models are instantly converted into 2D images or animation through a rendering engine. These are the main types of real-time rendering techniques. Scanline. This method is one of the traditional rendering techniques. Rendering techniques, the essence of scanline technique is the algorithm for calculating the surface of computer graphics. In a simple terms, the algorithm scans the top row of y coordinates of poly of 3D objects. Further, digital information, color, texture, effects is read from each poly and converted into a 2D images. Number 2. Z-buffer is a two-dimensional data system used to compute, optimize, and store of the depth value of each pixel. For example, when creating a render, the algorithm converts the 3D object into an image pixel by pixel, using the pixel closest to the camera first. In this case, the value of the pixel distance is stored in Z-buffer of cell. The primary purpose of this technique is to convey information about the distance of several rendered objects from each other and the camera and viewer. Z-buffer is often used in conjunction with the depth of field effect found in the toolbar of many software such as 3ds Max. This function creates the natural blurring of the object's background and sharpens the rendered object itself. Number 3. Shading and lighting. This shading process manipulates light and dark level using software effects. In this way, the rendering artist adds a natural effect and makes object appear more voluminous. For example, flat shading can sharpen the corners of an object. You can also use fading to create a subtle transition between the pixels and polygons of a shape. Lighting performs the same function as shading. It makes the scenes more natural and voluminous. For example, you can use artificial or daylight depending on the setting of a render. You can add volumetric lighting effects, such as how the sun's rays sift through a window or split with the volumetric lighting type. Another method is refraction, which allows light rays to bend on translucent surfaces. 4. Texture bump mapping. The texture is the top layer of a 3D model which displays information about the color, materials, and details of the object. Typically, a texture has multiple layers and wraps a model like wrapping paper. During rendering information about 3D texture is information about converting into a flat image. This requires the textures mapping technique, transforming the vectors of the 3D model and its texture into a pixel using unwrapping model. Bump mapping is similar to texture mapping. In its principle, only the first responsible for rendering 3D relief. This means that in a 2D image, various bulbs should look three-dimensional. Number 5. Ray tracing and recasting. One technique for working lighting and helpful rendering technique is a ray tracing. With it, you can set up a very natural lighting. For example, this method adjusts light based on the principle of diffusion, refraction of a light beam, and reflection, and also uses effects such as soft shadows. Usually, this method is applied for commercial purposes like advertising and product presentation. Ray tracing is rarely used in real-time rendering instead of ray casting. Ray casting is a second method of simulating natural light, generally considered easier to achieve. Thus, the scene is rendered with ray intersection In this case, the artists do not use light refraction and other natural effects. This method takes less time, but the result is less natural. One of the primary methods of real-time rendering is rasterization, a technique that converts geometric data into a 2D images. Rasterization in a computer graphics. Rasterization is a task that taking an image described in a vector graphics format and converting into a raster image. Other techniques of real-time rendering. Shadow mapping. Shadow mapping is just to simulate the effect of shadow in real-time rendering, the scene from the perspective of a light source and determining which areas are in shadow. Screen space and effects. Techniques like screen space reflection, screen space ambient occlusion, and screen space global illumination improve the visual quality of scene by considering pixel data on the screen. Level of detail. Techniques adjust to complexity of objects based on their distance from the camera. This helps maintain performance in a complex scene by reducing the detail of this thing. Post-processing effects. Real-time rendering often involves post-processing effects like motion blur, depth of field, bloom, and color grading to enhance the final image quality. Particle system. Particle systems are used to simulate various visual effects like fire, smoke, sparks, and explosions in real time by representing them as collections. GPU programming. Modern real-time rendering heavily relies on GPUs, graphics processing units, and specialized shaders to efficiently process and render graphics. These are the three main stages of rendering techniques. Stage 1. Geometric processing. Initially, the program generated a 3D representation of the virtual environment or objects by specifying their geometry comprising their shape, dimension, and position. This is usually done by defining a mesh of vertex edge and faces that form the objects in the scene. Stage 2. Shading. Next, the program applies shading to objects to make them look more realistic. The process of shading involves the calculation of lighting and shading effects on every pixel on the screen. This is determined by various factors such as the location of light source, the material properties of objects, and the position of the camera. Stage 3. Rasterization. Finally, rasterization converts objects into pixels that can be displayed on the screen. Rasterization allows you to add textures, colors, light, and darkness to your design. An important part of creating realistic images is working with reflection by adjusting light shadows. It is this stage that design begins to look realistic. Top 10 best rendering software for architecture and project design. Number 1. Enscape. In real-time architectural rendering, software that works as both standalone and as a plugin for some of the most used design software. It can be used for all design stages. The output in Enscape reveals high-quality renders with sharp colors and good lighting. It has an initiative user interface that requires a short time to create renders and is known as a great tool for creating VR experiences. Number 2. Lumion. Lumion is an architectural rendering tool that is user-friendly and initiative to use, so the learning curve is less steep compared to other tools. It is known for its high quality and fast rendering capabilities with numerous preloaded modeling elements. Twinmotion by Epic Games is becoming increasingly popular thanks to initiative features and interoperability. Number 4. V-Ray. Most architects and graduates will be familiar with V-Ray, known for its integration with SketchUp software. By Choose Group, it is now an industry staple that also provides real-time 3D visualization for any art and design projects. Guess it's safe to say real-time rendering is the new minimum prerequisite feature for an architectural rendering engine. Octane Render. Octane Render is considered one of the pioneers in GPU graphics processing unit, rendering a program that uses a graphics card instead of a CPU. It gives faster rendering process with accurate render output. Corona Renderer. No, we are only thinking about the dreadful virus. Corona rendering is an underdog among the architecture rendering software that is just as capable as the big names. Just Group, the home of V-Ray, is developer behind Corona Renderer. Number 7. Arnold. Arnold is ray tracing rendering software from Autodesk that is great for animation and visual effects. It can render complex images with a simplified workflow, pipeline, and user experience. Unreal Engine. Proudly claiming themselves as the world's most advanced real-time radio creation tool, Unreal Engine is making waves in the design industry. This architectural visualization software is a complete package when it comes to rendering expensive 3D worlds. D5 Render. This rendering software is fairly new compared to the other software in this list. However, its fast and reliable rendering capabilities are gaining interest in the chip industry. And number 10, KeyShot. It's an initiative standalone rendering software with a workflow-based interface and advanced 3D rendering capabilities. While many rendering tools support either CPU or GPU rendering, KeyShot supports both with an easy one-click switch.
Definition and term of global illumination and ray tracing. Global illumination and ray tracings are concepts and techniques commonly used in computer graphics and computer-generated imagery to simulate realistic lighting and shading in virtual scenes. Global illumination is a rendering technique that simulates the interaction of light in a scene to produce realistic lighting and shading effects. It takes into account not only direct light sources that illuminate objects directly, but also indirect light that bounces off surfaces and affects the overall illumination of a scene. Aims to replicate the way light behaves in the real world by considering complex phenomena such as reflection, refraction, and the diffusion of light. In direct lighting, global illumination calculates the way light rays bounce off surface and contribute to the illumination of the surfaces in the scene. Ray tracing is often used as components of global illumination algorithm to simulate the paths of individual rays of light as they interact with surface and the scene. Enhances the realism of rendered image by accounting for subtitle lighting effects like color bleeding, soap shadows, and ambient occlusion. Global illumination is used in various fields including video games, animation, architectural, visualization, and film production to create visual appealing and photorealistic image. Ray tracing is a rendering technique used to simulate the way that rays of light interact with objects in a scene. It traces the path of individual light rays as they are emitted from a camera or viewer and interact with objects in the scene. By calculating how this ray bounce, reflect, and refract, ray tracing can accurately determine the color and intensity of each pixel in the rendered image. Ray tracing involves casting rays from the camera through each pixels and tracing their paths as they interact with objects in the scene. Ray tracing can accurately model reflection, light bouncing off surfaces, and refraction, light bending as it passes through transparent materials to create realistic visual effects. Ray tracing is widely used in computer graphics for creating photorealistic image and is commonly found in applications like CGI for movies, video games graphics, and actual visualization and product design. In summary, global illumination is a broader concept that encompasses techniques like ray tracing as a means to achieve realistic and shading effects in computer-generated image. Ray tracing is a specific rendering technique that is often used as a component of global illumination algorithms to accurately simulate the paths of light rays in a scene. Together, this key concept and technique contribute to the creation of visual compiling and realistic virtual environment. In another, global illumination and ray tracing are both terms related to computer graphics and rendering, often used in the context of creating realistic image in 3D computer graphics. Global illumination is a rendering technique used to simulate the way light interacts with surface and objects in virtual 3D environment to create more realistic and natural looking image. It takes into account the complex interplay of indirect lighting, reflections, and refraction that occur in the real world. Global illumination methods aim to accurately model the indirect illumination of a scene by considering how light bounces off surface and contributes to the overall lighting. Common techniques for achieving global illumination include ray tracing, radiosity, and path tracing. Global illumination is particularly important for creating realistic and visually appealing scenes in computer graphics as it enhances the perception of the materials and lighting condition in virtual environments. Ray tracing is a rendering technique used in computer graphics to simulate the behavior of light rays as they interact with objects in a 3D scene. It models the path of individual rays of light as they are emitted from a light source, interact with surfaces in the scene including reflection and refraction, and eventually reach the camera or viewer's viewpoint. Ray tracing calculates the color and brightness of each pixel in an image by tracing these rays and simulating their interaction with the scene geometry. Ray tracing is known for its ability to produce highly realistic and physically accurate images with lifelike lighting, shadows, reflection, and refraction. However, it can be computationally intensive and has historically required powerful hardware for real-time applications. Advances in hardware and software have made real-time ray tracing more accessible in recent years, leading to its increasing adoption in video games and other interactive 3D applications. Global illumination is a broader concept that encompasses various techniques including ray tracing. For simulating realistic lighting in computer graphics, ray tracing is one of the specific methods used with global illumination to achieve accurate and detailed rendering of light interaction in a 3D scene. In order to represent real-world image with the computer, a program has to relate three-dimensional image on two-dimensional monitor screen. Several ways of doing this exist with varying degrees of realism. One of the most successful methods can be grouped in a screen-to-world method of viewing, which is also known as ray tracing. This computer graphics technology simulates light rays within a 3D environment. Since light rays have predictable physical properties, the ray tracing algorithm can attempt to calculate the exact coloring of each ray object intersection at any given pixel. Advanced levels of ray tracing allow light rays to bounce from object to object. What they do in real life, local illumination represent the basic form of ray tracing. It only takes into account the relationship between light sources and single object, but does not consider the effect that result from the presence of multiple objects. For instance, a light source can be intersected by another surface and therefore be obscured to any point behind that. Similarly, light can be contributed not by a light source, but by a reflection of light from some other object. The local illumination model does not visually show this reflection of light. Therefore, special techniques have to use to represent these effects. In real life, there are often multiple sources of light and multiple reflecting objects that interact with each other in many ways. Global illumination, the more advanced form of ray tracing, adds to the local model by reflecting light from surrounding surfaces to the object. A global illumination model is more comprehensive, more physically correct, and it produces more realistic image. Ray tracing is an essential subject. With its come to computer graphics, it combines issues of efficiency and realism. Those findings are favorable balance of the time and effort involved to make realistic three-dimensional image. In the process of researching many different ways of implementing a ray tracing, the study began with local illumination and graduated of global illumination, using some pre-established techniques in the development of new techniques.
Good morning, sir. I'm CARLO and JJ BELTRAN from ACT2E. Then, this is my part about the understanding visual reality and augmented reality. We spend a lot of time looking for a screen this day. Computer, smartphone, and television have all become a big part of our lives. They are how we got a lot of our news, we social media, watch movie, and much more. Visual reality VR and augmented reality RA are two technologies that are changing the way we use the screen, creating news and exciting interactive experience. Visual reality used to headset to place you a computer generate world that you can be explore argument. The reality and the other hand is a bit of different. Instead the transporting you had to visual world and take the digital images and layer them on the real world around you through this use for either a clear visor or smartphone. Then, with visual reality, you could explore the underworld environment, which augmented reality is you could see fish swimming through the world around you. Then, visual reality. Visual reality is immerses you in a visual world through the use of headset with some types of screen displaying visual environment. These are headset and also use the technology called head tracking, which allow you to look around the environment by physically moving your head, and this display will you follow whichever direct you move, giving you a 360-degree. Type of VR devices. At the moment, there are two major types of headset. Both are their pros and cons. Pros is pros is to give a details connect which the people effectively communication, and cons he used to addicted to visual world technology is still experimental. Training in VR environment is not real, which all you have all want to consider is if you are looking to purchase one, the first step of a screen built into the headset. Their device connect to the computer and required to pretty powerful system operate monthly. They have a great graphics and perform well, but they are also pretty expensive. Then a few popular example of this is include to Oculus Rift, the Vive, and the the PlayStation yun. The PlayStation which connect to the PlayStation 4 game console. Oculus Rift, they are designed to connect the high-powered PE to enable to advance the computation and graphics rendering. By our visual reality brand ano to? By a visual reality brand of HTC Corporation, they are promote the application of visual reality in in sector like business and video gaming. Ito po yung mga games na nakalagay po sa visual reality na sa VR. Then the PlayStation VR, no by its code name is Project Morpheus Development. It's visual reality headset developed by Sunny Interactive Entertainment, which was released in October 2016. Some of these devices come with handheld controller that track your hand movement and will providing for more interactive experience. The other of headset houses you po and use the screen to display. They don't require the computer and run to completely off apps on your smartphone and graphics and performance level on this headset are not quite as good as choose with a built-in screen, but they do not tend to be much cheaper. Some popular examples include to Google Cardboard and Gear VR. Google Cardboard is used to view a picture, play games, and experience visual reality through a VR view that you can buy or make it home. Then Gear VR is a visual reality headset developed by Samsung and collaborated with Oculus.